Hello! Today we are going to examine facilities with HACCP applications and their case study demonstrating changes in order to learn more about the practical establishment of HACCP system and the operation method. HACCP is a preventative system possesses two functions. It scientifically analyzes the situations where biological, chemical, physical hazards may exist during a manufacturing process, and this system prevents causes of remained hazards or contamination in advance. It is a prevention system for food safety management to provide safe and sanitary food to customers as well as to prevent any hazard. HACCP employs a systematic operation method that is composed of 12 steps with 7 principles, 5 preliminary steps, and 7 main steps. 7 principles and 12 steps is a process that builds a complete management system. So, from now on, we will be looking into essential factors in 7 principles and 12 steps that you must learn. The first step to develop HACCP plan is to assemble a team that will play a leading role in HACCP plan development. HACCP team directs all work related to HACCP system operation. In detail, the team is in charge of prerequisite program development, HACCP system development and examination, system improvement and operation, coordination with another team, development plan research for HACCP, and so on.
CEO's willingness has a decisive effect on HACCP implementation and its successful operation. So CEO should participate directly in one way or another when assembling the HACCP team. And also, the team should include key members of the company. Generally, it is recommended that the chief executive or the facility manager should be a team leader of HACCP team, and team members should be composed of manufacturer, operation manager, PR manager of facility, equipment, manager of storage, logistics department, the manager and members from Quality Control Department for food hygiene, healthcare manager, HR manager for education, training. Also, a person who is in charge of monitoring should be designated from field workers operating the related equipment so that management about the site can be much easier. Members of HACCP team shall receive a HACCP training and reach a certain level of expertise. The team member who participates in HACCP plan development shall possess detailed knowledge and experience about facility, equipment used in the manufacturing process, and the necessary skills, actual working environment, hygiene, quality assurance, and characteristics of the process. Otherwise, it is very likely to establish standards that are far removed from actual working situations. Also, HACCP team organization and personnel status, duties and rights of HACCP team members for shift work, detailed transition method for each team shall be documented and maintained.
The second and third preliminary steps are to write product descriptions and identify its intended use. The product's descriptions will be used as materials to confirm any hazard related to the product and to assess the risk of confirmed hazards. They also become important data to set critical limits and critical control points in respect of the product's properties.
The product descriptions must include necessary items such as product name, product type and properties, report date of product manufacturer, writer's name and reporting date, mixing ratio and manufacture method of properties, food materials, manufacture unit, dimensions of finished product, precautions on storage and distribution, intended use and distribution period, packaging method and the quality of the materials, indications, etc. It is recommended to write a product description for each product. However, if same or similar characteristics are appeared in processes for each food, therefore, it is deemed safe to write descriptions for each type of food. It should be allowed to put foods together or write for each food type. For end users or customers, confirming the intended use of a product shall be conducted, and especially, it needs extra attention when manufacturing foods for vulnerable consumers. The general form of product description is as follows, and each facility is supposed to make an appropriate form of product descriptions that is most suitable for your facility.
As the fourth preliminary step, HACCP team studies all processing steps from raw material receipt through to finished product distribution, which are directly under the control of the manufacturing facility to make the process flow diagram and to write main manufacturing conditions for each processing step. While making the process flow diagram, it would be a good idea to make a clear table that shows manufacturing methods for each processing step in detail.
A floor plan is a drawing that indicates facility name and section names reflecting the characteristics of each manufacturing facility. Using this floor plan, it is possible to understand the risk of cross-contamination caused by workers, logistics, water drainage, ventilation, etc., as well as to establish preventative measures. The process flow diagram and floor plan are very helpful to understand hazards, cross-contamination, and any potential hazard, such as secondary contamination, or its growth in all processing steps from raw material receipt through to finished product distribution. The fifth preliminary step is to verify that the process flow diagram and the floor plan are identical to actual conditions of the site. HACCP team directly checks each step of the process on site to verify that the process flow diagram and floor plan are identical to actual working processes. The purpose of making the process flow diagram and the floor plan is to find any condition and point that might occur hazards in each process, and in the facility to ensuring accuracy is very important. Therefore, if there is any indication that requires modifications after the verification on site, the corresponding process flow diagram or floor plan should be revised. When accurate process flow diagram and facility floor plan are all prepared, it is considered ready to fully implement HACCP plans.
The first principle for developing a HACCP plan is a hazard analysis. A hazard analysis is conducted by HACCP team and divided into two criteria. One criterion is conducting a hazard analysis for each of raw material or ingredients indicated in the product description, and the other criterion is conducting a hazard analysis for each of processing steps indicated in the process flow diagram.
Through this step, potential hazards for each raw materials, ingredients, or in each process step should be discovered, and the list of the hazards should be written. Inflow path of each hazard and its control measures should be studied and addressed. Considering such inflow paths and control measures, likely occurrence of hazards, and the severity of the result from the hazards should be identified to assess the risk. The first step of hazard analysis is to address and catalog all biological, chemical, and physical hazards for each material, process, and their causes. The methods are finding related documents about the process of the facility, material review through field survey, field analysis, and so on. Secondly, evaluate the severity of identified potential hazards. The evaluation is conducted based on the severity of identified hazards. The assessment is based on all conditions caused by identified biological, chemical, and physical hazards, occurrence frequency, and likely occurrence. Criteria of likely occurrence are established based on test data about surrounding environment and statistics of the filed test that is conducted on an actual production line with regard to identified hazard for each raw material, ingredient, and process. The next step for hazard analysis is to find and write preventative measures that completely remove and prevent identified potential hazards and their causes to a safe level or reduce them to an acceptable level. These preventative measures might require more than one method, and with one preventative method, several hazards can be under control. Only preventative measures that can be performed under current working conditions shall be written. Lastly, the analysis list of previously analyzed hazards should be made and maintained thoroughly. This information can be used in various ways, such as re-evaluation of HACCP plan, establishing corrective measures for critical limit deviation, seeking countermeasures for unpredicted hazards, etc. Being unable to conduct an accurate hazard analysis hinders the establishment of effective HACCP plan. Therefore, a hazard analysis is a very important step that needs to be done with rigor.
The second principle of HACCP is to determine critical control points. A critical control point means important stage, step, or process that secures food safety by preventing, controlling a food safety hazard, or reducing it to an acceptable level through application of accreditation criteria for food safety management.
Examples of critical control point in food manufacturing process are as follows. However, even when an identical product is being manufactured, working environment can be different by manufacturing equipment and so on. Thus, the examples of critical control point can also be changed. The best way to determine critical control points is through a decision diagram for critical control points. This diagram should be applied for critical hazards that are designated in the first step of hazard analysis. Put hazards in the decision diagram and write its result in a decision table.
The third principle of HACCP is to set critical limits for critical control points. Now, we just looked into the critical control points, then what is a critical limit? A critical limit is standards that determine whether or not controlling hazards is within an acceptable range. In other words, it means the maximum or minimum value that prevents, eliminates, or reduces biological, chemical, or physical hazards in critical control points to an acceptable, safe level. These critical limits must be established founding on a scientific basis that ensures safety.
Critical limits should be indicated using easily recognizable figures or particular figures, which allow a visual observation or a simple measuring process on site. When determining critical limits, various conditions such as legal requirements, research papers, specialized books about food, advice from experts, basic data on manufacturing process need to be considered. For example, items requiring critical limits are lowest temperature and center of a product when heating it up, minimum time to freeze a product to a certain temperature, size of any possible metal piece, foreign substance, etc. Critical limits shall be established in the following procedures. First of all, check legal standards and criteria for food. If the legal standards are absent, the facility establishes its own standards, and then file evidentiary materials about the established standards.
The fourth principle is to establish a monitoring system which effectively manages critical control points. Monitoring is to observe and measure the process that is considered a critical control point using a human resource or mechanical method in an effort to run the process stably within critical limits.
Monitoring should be managed consecutively, and if not possible, the cycle of non-consecutive monitoring should be set accurately enough to manage critical control points within the range of critical limits. Maintaining the monitoring result should be performed by a person who has knowledge, experience, and authority to take corrective actions. Therefore, a person who is in charge of monitoring shall be sufficiently educated, trained technically to properly check monitoring items for critical control points with an appropriate monitoring method. Also, it is better to record the exact figures from actual monitoring result rather than to simply record yes or no, or accepted, not accepted. Monitoring system should be established in the following order. A recommended monitoring method is setting a method and cycle that are easy and quick for field workers to perform.
The fundamental objective of HACCP is to establish preventative system that finds out and modifies problems before food hazards occur. That being so, it is important to establish corrective actions in advance in order to take countermeasure in a prompt manner when monitoring shows it exceeds critical limits.
To easily find corrective actions, a checklist, as shown here, can come in handy. General corrective actions include reset of the process, measures for foods that were affected by critical limit deviation, investigation of the causes, reoccurrence prevention, changes in HACCP plan, and so on. After taking corrective measures, please check the following items to learn effectiveness of the corresponding measures.
Verification means checking if HACCP management plan is well established and maintained properly. Verification procedures often divide into two aspects: validation and feasibility.
Verification for validation is to verify that HACCP management plan and prerequisite management standards, including hazard analysis, determination of critical control points, establishment of critical limits, etc., are valid. In this procedure, scientific verifications, such as standards inspections for end product, cleaning disinfection, etc., are conducted. Verification for feasibility is to verify that HACCP management plans and prerequisite management standards, including hazard analysis, determination of critical control points, establishment of critical limits, etc., are properly maintained on site. Confirming documents, such as monitoring records or status check sheet, and checking whether or not management plans are implemented on site are ways to verify feasibility. During the verification, it is essential to perform initial verification that checks if the initial step of HACCP management plan, in other words, corresponding plan sheet, can be applied on site and yield effective results. After improving, compensating the problem through this, fully apply the HACCP management plan. Afterwards, in order to check validity and feasibility of the applied HACCP plan, conduct verification steps on a regular basis. Also, if there is any problem in foods or any practical change or new information on the process, a special verification should be performed.
Lastly, seventh principle of HACCP is to establish record-keeping procedure that documents HACCP system. Record keeping is essential to HACCP system, and without record keeping, HACCP system is inefficient and lacks grounds to operate the system. Therefore, detailed records about operation of HACCP plan must be present. The best record keeping is a simple, comprehensive form, and it allows readers to understand necessary records easily. In order to do so, it is required to devise the simplest and easily understandable form after reviewing and considering the previous record method, optimum recorder and reviewer, record date and cycle, period and location of record storage, etc.
Documents related to HACCP system operation are as follows. These documents play an important role in proving that the facility complies with HACCP management plans before distributing products.
So far, we have learned 5 preliminary steps and HACCP's 7 principles. Once the HACCP management plan is established according to the steps and principles, this plan should be charted, written, and maintained according to a list form for HACCP plan. Then, shall we look into actual facilities that implemented HACCP and how they have changed?
This facility manufactures meat processing products. In this facility, As you can see, they made process flow diagrams for each product they produce. After making process flow diagrams, it becomes possible to quickly notice where is at risk of having cross-contamination. Also, with a facility floor plan, they control any potential cross-contamination during transportation. Based on the facility floor plan, they see the likely occurrence of cross-contamination caused by logistics, drainage, ventilation, etc., and establish preventative measures. Also, a facility layout showing locations of equipment in the facility allows more systematic and thorough management. The process flow diagram and floor plan are very helpful to understand hazards, cross-contamination, and any potential hazard, such as secondary contamination or growth in all processing steps, from raw material receipt through to finished product distribution. The next shows how corrective actions were implemented after realizing critical control points that are at risk of hazard occurrence. This facility uses a mincer for meat processing. Using a mincer contains the hazard that metal foreign substances can get into food. So, in order to prevent metal foreign substances from mixing with food, they installed and have operated a metal detector. Also, they do not neglect to install SOP about the operation of the equipment and to keep a record of use attentively. Furthermore, since this facility handles meat, it is most important to handle raw materials at a proper temperature. This facility designates storing raw meat and finished products and temperature management as critical control points, and thoroughly keeps the temperature within 2 to 5 degrees below zero, which is considered proper temperature. The critical control point for this ham manufacturing facility is sterilization process. The facility takes measures to maintain that core temperature of smoked hams is over 75 degrees, and the surface temperature of the hams during secondary sterilization is 75 degrees plus, -2. The next facility is a beverage manufacturer. The most critical control points in beverage manufacturing are sterilization, filtration, and bottle washing. This facility introduces automation system for the important process. The most important thing in sterilization is temperature. This process automatically shuts down if the temperature does not meet the critical limit. For this, it is equipped with temperature management devices, and also all workers in the facility can check the temperature. For filtration process, which is another critical control point, strainer condition is frequently checked before and after the operation, and also it is maintained with thorough record keeping. To prevent cross-contamination generated in a washroom, this facility removes hand towels and install a hand dryer instead. Also, to strengthen personal hygiene, they place hand sanitizers. They additionally install a hand disinfection device on the outside of the washroom door, which will meticulously prevent cross-contamination caused by the washroom knobs. Now, let's take a look at a dressing room. Since a dressing room is very private, it might not have sufficient maintenance. Workers of this facility stores a disinfected overgarment in the upper side of a locker and everyday wears in the lower side of the locker, which prevents cross-contamination caused while changing clothes. Also, to make cleaning easier, the upper side of the locker has a slope. In a shoe shelf, indoor work shoes and outdoor shoes are separately placed to prevent cross-contamination. Why don't we take a look at the entrance connecting to the facility? They put up a notice about standards for proper clothing. Also, it is well equipped with sanitary devices for hand washing, drying, disinfecting. It has a separate section to wash the work shoes, removing and preventing potential foreign substances. Lastly, it installs a footstool for disinfection to control any possible inflow of pathogens. It shows well-built hygiene system that leads to the facility, which is a clean area. Any tool that is used to manufacture food is considered to be a critical control point too. This facility self-produced the storage box for knives in order to prevent contamination caused by foreign substances and germs dropped on the products. The storage box also makes it easier to store and maintain blades separately. Furthermore, separate storage of gloves, aprons, arm sleeves, frequently used on site, prevent cross-contamination. Likewise, clean area and general area use separate cleaning tools in an effort to pay more attention to the hygiene of the clean area. Shall we take a look at the facility? When equipment used in the facility directly touches the floor, it is possible to have hygiene issues, such as foreign substances getting into the products. So this facility eliminates potential contamination in advance by installing all equipment at a certain distance from the floor and walls. In this case, it was difficult for the facility to get a new device to solve the problem. So instead, they solved the problem quite easily by making floor boxes when storing items. It is also important to manage the moving lines well in the facility to reduce cross-contamination caused by movements. This facility uses a tape that has the different color from the door in order to segregate a moving line for workers from a moving line for raw materials. Using tapes, it shows a simple solution that indicates moving directions and divides sections. Temperature control systems for refrigerator and freezer are the ones that food manufacturing facilities need to put so much effort to properly maintain. This facility installs temperature criteria SOP for each refrigeration equipment and records temperature maintenance logs every hour. When loading items in the refrigeration equipment, they use pallets to prevent raw materials from touching the ground and manages the materials by thorough record-keeping on dates and times for first in, first out. Vermin and rodents are great threats to food hygiene. To prevent them, many facilities employ insect control methods, such as traps, flypaper, etc. This facility analyzes the amount of captured insects and operates a countermeasure device based on the analysis. Also, this facility shows how they control and prevent an inflow of potential hazards by installing filers in vents and drain pipes. If any piece of the broken lamp in the facility gets into products, isn't it obvious it would become a real hazard? This facility installs a shatterproof cover to prepare for any potential accident. According to HACCP standards, illumination of the working section where visual inspection is an important step shall be above 540 lux at least. This facility creates a separate check table for illumination for maintenance purpose.
So far, we have learned about 7 principles and 12 steps that constitute HACCP operation system, as well as several facilities operating hygienically and safely through the applications of HACCP program. With today's lectures, hopefully you are encouraged to participate in HACCP actively and to meet your consumers with great products and pride. It has been a pleasure to give these lectures about HACCP. Thank you.